All right, this is a big thing to remember. If you have a bunch of parallel lines and you have a transversal running down the line, and that transversal is cut into congruent segments, then any transversal you draw will be cut into congruent segments. So once again, these congruent segments mean that each of these are congruent. So that would mean that 3x minus 7 would equal 11, which means that 3x would equal 18, which means x equals 5, right? Yeah. So the correct answer was A, 5. You were all wrong. No, it's 6. Everyone was right. I gotcha. All right, then we have another one. Another equation that'd be 5x minus y equals 11 as well. Now we could take that 6 and plug it in there. And we could have 30 minus y equals 11. Negative y is going to equal, so I'd subtract 30 on both sides. That says 33, but I'd subtract 30 on both sides. And I'd come with negative y equals negative 19. Which means that y would equal 19. Any mistakes, or is that what we got? That's what, okay, if someone got it, then I'm good. All right, the second one. Now, there's a whole bunch of things that go along with a parallelogram. But I was looking for basically the 4 big ones that you should think of. Go ahead and have that sheet. Can someone name one of the big things that is important about a parallelogram? Sangha. What was that? It's a parallel? Yeah. Let's put that as opposite sides are parallel. Okay. Yeah. So opposite sides are parallel. That is by definition what it is. What's another thing that's important to think about when you say parallelogram? Yeah, Krupa. The diagonals bisect each other. All right, someone name another one. Yeah. Oh, sorry. I should have said it because as soon as you did it, Jacob raised his hand. But yeah.
Opposite angle and side are congruent.
Let's just go with opposite angles are congruent. You can't steal all of them. Opposite sides are congruent. Now, those are the big things that deal with a parallelogram. When we start talking about 90-degree angles, or angles bisect, or diagonals bisecting angles, then you're getting into specific parallelograms like rectangle, rhombus, or a square. These are the 4 big ones that deal specifically with parallelograms. All right, questions on that? Yes?
So all 4 of those, they apply to all of them?
All of them. So all 4 of these apply to a rectangle. All 4 of these apply to a rhombus, which means all 4 apply to a square. It's just a rectangle has additional properties, and a rhombus has additional properties as well. All right, questions from the homework? Questions from homework going once? Twice? Hey, once again, I'm just going to quickly remind you, make sure you're checking your answers. Because if I walk around in that one, if I'm pointing something out to you that is wrong, it means it's the one I'm checking and you lose 1 to 2 points because you didn't check it. All right? You might have had everything else correct, but you just didn't take the time to quickly check it. Make sure you check your answers so you don't lose that point or 2 every single time. All right, then let's go into today's lesson. Today's lesson isn't anything new. Bum, bum, bum. We start with a parallelogram. That's what we started with in the beginning of this section. Then we talked about properties of rectangles. Particularly, a rectangle has 90-degree angles, 4 90-degree angles. And that led us to, if a parallelogram is rectangle, then its diagonals are congruent. So that was that theorem we came up with. We also had the reverse. If one angle is a right angle, then a parallelogram is a rectangle. This also led to our triangle theorem, that if we had a median and a right triangle, everything is equidistant. So in that picture down there, if this is a midpoint, right, if that's a midpoint, then that is congruent to that, is congruent to that. Don't forget about that with right triangles. Finally, we talked about a rhombus. A rhombus is just something that has four sides. So it's a parallelogram with four congruent sides. That led us to, if a parallelogram is a rhombus, then its diagonals are perpendicular. So a rhombus has perpendicular diagonals. It also has the diagonals bisect the angles of a rhombus. All right, those are the big things we talked about on Friday. What's cool about a square? Maybe I just think it's cool. Yeah, Krupa. Has all of those properties. Because a square is a rhombus, it is a rectangle, and it is a parallelogram. So anything you can say about a parallelogram, rhombus, or rectangle, you can say all of those about a square. So every one of those theorems that we learned about parallelograms, rectangles, and rhombuses apply to a square. All right, the reason why we're not learning anything new is because today we're going to actually use those theorems in proofs. And we're going to do this first proof together just to remind you what is writing a proof, because we haven't really done any this time. So we're going to write a proof together, and then the rest will be your homework. All right, we are given a rhombus ABCD. In the back of my mind, I'm thinking, why is being a rhombus important? What makes a rhombus unique? We know it's a parallelogram, but what makes it a unique one? Yes? Its diagonals are perpendicular, so we'll think about that. What else is important about a rhombus? Diagonals are perpendicular. Yes? All sides are congruent. What's the last thing I can think about when I read the word rhombus? There's one more theorem that goes with a rhombus. Has to do with your diagonals. Yes? Yep. Its diagonals bisect their opposite or the angles. All right, so all three of those should run through your mind as soon as you read the word rhombus. We need to end up proving that angle ADE is congruent to angle CDE. So let's just write down our givens. First and foremost, so we have a rhombus, A, B, C, D. And second of all, we have AE is congruent to CE. And that is going to be given. Yeah. Yeah. All right, before I get to step 2, I'm just going to mark down that AE is congruent to CE so I don't forget it. So AE is here. And we have CE is right here. Those two things are congruent. I need to get to angle ADE. Let's focus where ADE is. So I want to prove that this angle here is congruent to that angle there. All right. Who has an idea of how we could do that? Yeah, Labib.
Angle A equals angle C.
Mm-hmm.
Theorem 513.
That is true. I don't think it's going to help us here. It might. But I can't figure out how to get from that angle to that angle. I'd have to think of a way to get from that angle to that angle. And I can't quite think of a way to do that. So it's true, but it might not help me on this one. Alicia? AD equals DC. That one I think will help us. And how do I know that AD is congruent to CD? It's a property of a rhombus. And there's no theorem if it's just what a rhombus is. So a rhombus, by definition, is a parallelogram with all congruent sides. So that's just going to be definition of a rhombus. What could we do next? John?
Angle E is congruent to angle E.
Angle E is congruent. I think you're trying to say this little angle is congruent to that little angle.
Oh.
Or are you saying the whole, because there's actually 3 angle E's. There's AED, there's DEC, and then there's AEC.
Okay.
Do you see all 3 of those angles? What are you trying to do with that, I guess? If we knew angle E was congruent to angle E, what could we do with that then?
You would show that DE is side.
You got it. Say,
Side DE
is,
congruent to side DE.
there you go. Side DE is congruent to side DE. And it's the same property, right? That reflexive property. Do you see how E, because there's 3 E, if there was just 1 E, then you could say it. But since there's 3 of them, they're not all congruent. We don't know that for a fact. So what would our next step be? We just proved a whole bunch of sides are congruent. Jacob.
Triangle ADE is congruent to triangle CDE.
All right, triangle. I'm going to say it in your order. I missed it. You said it too fast. Triangle
ADE
ADE.
CDE.
Is that written correctly? I'm not saying it isn't. I want everyone to take a second and look at it. Is that written correctly? No one disagrees? Okay. And then you said by
Side, side, side.
side, side, side. Step 5, someone that hasn't been involved in this proof yet. Emma. Yeah, is congruent to angle CDE by CPCTC. So some of these, you're going to go down kind of an errant path, and if it's not working, just go back and try some other fact. So we started off with A is congruent to C. I couldn't think of how to get that to an angle, so I tried something else. I took what was important about being a rhombus and that we have congruent sides, and then we built 2 congruent triangles, or we showed that those 2 triangles were congruent, which got our parts congruent. All right, questions about this proof? All right, then the rest of the time is yours to work on these proofs. Just a reminder, we do have a test on Friday. We have 2 review days, that's Wednesday and Thursday, which means we just have 1 more lesson in this section. Tomorrow we'll talk about trapezoids, and then we're done with chapter 5. All right. The rest of the time is yours.